Swayam Prabha. Digital India. Educated India.
Hello viewers, welcome to lesson 4.2 traffic loading part 1 of payment design, which is being covered under module 4. We would be covering traffic loading in two different parts. This lesson pertains to part 1 of traffic loading parameters. In the last class, which was on principles of payment design, we have discussed about three very important external parameters which are external to the payment that need to be considered for design of payment. First one was update, second one was traffic parameters, third one was climatic parameters. So, over the next two classes including this, we will be covering various traffic related parameters, which is a very important input for payment design. In this lesson, we will be covering various aspects of traffic related parameters. So, after having understood this lesson or gone through the contents of this lesson, it is expected that the student is able to appreciate the need to consider various traffic related parameters in payment design, what is the importance of considering different parameters that pertain to traffic loads in payment design, and also will be able to learn and understand about the different configurations of commercial vehicles and understand the mode of load transfer to the payment, and learn in general about the procedure that is followed for estimation of design traffic for payment design. When we consider traffic loading, obviously we are referring to vehicles. We also know that there are different types of vehicles with wide ranging sizes, wide ranging load magnitude and ability to travel at different speeds. We can start with bicycles, two wheelers, passenger cars. We have vans of different sizes and shapes, buses, different types of trucks, single unit trucks, multi unit trucks. So, we have various combinations, various types of vehicles that ply on roads or highways. We have to consider which one of these vehicles are important for payment design, which one of these vehicles that we need to consider, which specific parameters need to be considered as inputs for payment design. For example, in evaluating the traffic condition, the quality of flow on a given road, and also in assessing the adequacy of geometric design features, all these aspects we have studied in the earlier lessons. It would be necessary to consider all these vehicles that I have listed in the previous slide, whether it is small or big, whether it carries small load or heavy load. All those things, all these vehicles are important from the point of view of geometric design consideration, because we provide specific geometric design features for specific design vehicles. That could be bigger vehicle, that could be smaller vehicle, and many times we understand that it is a mixed traffic that has to be utilizing the facility. So, accordingly the geometric design requirements of each one of these vehicle is taken into consideration and the specifications are accordingly provided. Similarly, when we are assessing what is the quality of flow, what is the effect of small vehicle, what is the effect of big vehicle, on the quality of flow has to be taken into account. So, under those situations all vehicles are important, but whereas when we are trying to design pavement as a structure, the loads that these vehicles carry is of more relevance to us. So, as a result, we normally do not consider the smaller vehicles in pavement design. For example, bicycle we normally never consider for pavement design because they do not carry any significant load. Even passenger cars we do not consider. So, what we consider is only commercial vehicles. Indian Roads Congress defines commercial vehicles as the vehicles having a laden weight more than 3 tons, including its self weight. Self weight plus any other load that it carries, the total weight if it exceeds 3 ton. So, the type of vehicles that carry including self weight more than 3 tons, we can consider them to be commercial vehicles. So, we normally consider only these vehicles which we call them as commercial vehicles for designing pavements. And in a given traffic composition, what is the percentage of these vehicles, how many are there? So, that is what we are going to be interested in. Typically, commercial vehicles can be trucks, buses, vans, and when we refer to a commercial vehicle, we talk about its gross load, we talk about its axle load, we also are interested in the wheel loads. Ultimately, it is through the wheels that the load is transmitted to the pavement, but agencies such as the road transport agencies and other people, commercial tracks and other people are usually interested in the gross load that is carried. For example, in this case, if you consider a gross load of 200 kilonewtons, that as you can see is transmitted, this vehicle has got 2 axles and this is distributed over these 2 axles. Let us assume the first front axle carries about 80 kilonewton load, and the rear axle obviously carries the remaining load, that is 120 kilonewtons. Now, gross load is 200 kilonewton, front axle load is 80 kilonewton, rear axle load is 120 kilonewton. Most of the weigh bridges that you see on highways, they are only meant to weigh the gross load because that is what most people are interested in. But as pavement designers, we are interested in what is the load that is coming on each one of those axles, and in fact we are interested in what is the load that is coming on each individual wheel. For example, let us assume the front axle of this particular vehicle had one wheel on either side. Then as indicated there, it was carrying 80 kilonewton. So, if we assume the load to be equally distributed uniformly over the entire vehicle from left to right, you can assume the load to be distributed equally on both wheels, then it would be about 40 kilonewtons each. If we assume the rear axle to be of this configuration, these axles can be of different configuration. They can have single wheel on either end, they can have what is known as dual wheel set, as you can see this is a set of 2 wheels. So, we have one dual wheel set here, another dual wheel set here. Now, on each one of these dual wheel sets we have 60 kilonewton applied because we consider about 120 kilonewton on the rear axle there. Besides the axles that have single wheel on either side, dual wheels on either side, you can also have what is known as a tandem axle as shown here. Tandem axle is nothing but 2 separate dual wheel axles, but working as one single unit. There will be a mechanism to ensure that the load transfer is there over both these axles, and both these axles together will function as one single unit called as tandem axle. So, we normally have axle having single wheels on either side, axle having dual wheels on either side, or a tandem axle unit. So, any vehicle will have a combination of these 3 types of axles. It could be only 2 axles, it can be multiple axles, but what is the combination of axles that is there on a given vehicle will decide what is the load that this particular vehicle can carry. As you can see here, commercial vehicles can come either in single or multiple units. It can be one single unit or it can be number of units also. So accordingly we call it as either a single unit truck having 2 axles or more axles, or vehicle trailer combination, which is either a semi trailer tractor combination or tractor trailer combination. We will see what these combinations are in the next slide. So we basically have single unit vehicles, we have semi trailer combinations, we have tractor trailer combinations. This is typically the loading configurations that Indian Road Congress considers. The first two types of vehicles are single unit type. The first one is a vehicle having 2 axles, single unit, you can see it as a single unit there. The second one has got type 3, it has got 3 axles. In fact, this is a tandem axle, you have single axle here and a tandem axle, that is considered to be 3 axles there. These are semi trailer axles having 2 axles. This is a semi trailer axle having 2 axles in the trailer. This is a 3S1, 3 in the tractor and then 1 in the trailer. So accordingly you have different combinations of axles, different combinations of whether it is a single unit, tractor trailer unit, this is a semi trailer unit, these are tractor trailer units, this is a tractor unit, this is a trailer unit. In a semi trailer unit, a major portion of this load is carried by the tractor unit. As you can see, it is transferred onto the tractor unit, but whereas in this case you have an independent tractor unit and a trailer unit, okay, this one only tows the trailer unit. So you can have different combinations of these vehicles. So Indian Road Congress also gives us what is the permissible limit on each one of these axles or each one of these types of vehicles. For example, if you have an axle having single tire on each side, then the permissible limit is 6 tons. So if you have a vehicle having 2 axles, both having single wheels, then you can have on the front axle weight can be 6 tons maximum, rear axle weight can be 6 ton. So naturally the gross weight of the vehicle will be 12 ton. But if a truck has again 2 axles, but front axle being single wheel axle, rear axle having dual wheel sets, then the front axle maximum weight that can be put on this is 6 tons. Rear axle, if you have a dual wheel sets on either side, permissible limit is 10.2 ton, then that particular vehicle can have a total of 16.2 ton as permissible total gross weight. Similarly, if you have tandem axle, 18 ton on tandem axle, so single axle plus tandem axle 24 ton, single axle plus 2 dual wheel sets, one on the tractor, one on the trailer, then total is 26.4 ton. One single axle having single wheels on either side, one tandem axle, these two are there on the tractor unit, and you have one tandem axle and then one axle having dual wheel sets, so the total would be about 52.2 tons. If you go on adding more axles of different types, the total gross weight that is permitted on a given vehicle will be increasing. The load transfer through wheels, because we have seen that there is a gross load is transferred through number of axles, and each axle in turn has got 2 sets of wheels on either side, whether a single axle or dual axle, single wheel or dual wheel, So, ultimately it is through the wheels the load is transmitted to the pavement. Let us see how it gets transmitted. We normally use pneumatic tires. Which are inflated with air, and in this case there are three important parameters that we need to consider. What is the total weight that the load is wheel is transferring, what is the shape of contact area, and what is the distribution of pressure over the contact area. Let us consider how the contact pressure is distributed and how to estimate that, how much of a contact pressure is to be considered in our analysis or design. If the tire inflation pressure is low, how much would be low is a function of what is the type of tire that we are using, what is the type of pavement that we have there. So, taking into consider all those things, if you know how much is low, if the pressure is low, then the walls of tires will be in compression. So, as a result the contact pressure is going to be greater than the tire pressure. So, obviously the contact pressure cannot be taken exactly equal to the tire pressure, it has to be something different, it will have to be more than the tire pressure. On the other hand, if the tire inflation pressure is high, again we have to define what is high, which is again a function of what is the type of pavement and what is the type of tire that we are referring to. In this case the walls of tire are in tension. As a result the contact pressure will be less than the tire pressure. So, if we want to take accurately the contact pressure has to be taken as somewhat less than the tire pressure. There are some rough guidelines available as to how to select this. This can be represented in the form of rigidity factor, which can be defined as contact pressure by tire pressure. If the tire pressure is about 0.7 MPa, then you can assume the rigidity factor to be 1, that means the contact pressure would approximately be equal to tire pressure. That is the situation when you are going to have about 0.7 MPa tire pressure. So, the rigidity factor will be about 1, but if the tire pressure is low, being less than 0.7 MPa, then the contact pressure is going to be more than tire pressure, as we have seen in the previous diagrams, then the rigidity factor is going to be more than 1. If the tire pressure is more than 0.7 MPa, then the contact pressure is going to be less than tire pressure. So, the rigidity factor is going to be less than 1. But obviously for all this we need to get a complete information about, if it is 0.6 what will be the rigidity factor, then how much the contact pressure can be assumed to be. You need accurate information about all this. But normally we consider tire pressure to be equal to inflation pressure, and then rather the contact pressure to be equal to tire pressure, which is in turn is equal to the inflation pressure, and we normally calculate contact pressure to be wheel load divided by the area of tire imprint. So, important thing is we make an assumption that the contact pressure is equal to tire pressure, although we know that it is not always the case. The load is transmitted to the pavement surface in different modes. We can have vertical stresses, we can have unidirectional surface shear stresses, we can have centripetal stresses. So, in a given situation you can have a combination of these modes for transfer of load to the pavement surface. Vertical stresses, it is obvious, a load is acting vertically on the, most of the time it is acting vertically on the pavement surface. So, you are going to have, or the pavement is going to be subjected to vertical stress, but it is possible that unidirectional shear stresses can be applied to the pavement surface, especially when the vehicle starts accelerating, there is braking action, or the vehicle starts from a stopped condition. In that case there is unidirectional shear stress applied on the pavement surface. So, we would need to be considering these stresses also. We can also have centripetal stresses on the pavement surface acting within the contact area. These occur because of the inflation pressure acting in different directions and then trying to push the tire away. As a result, you have this centripetal shear stress acting within the contact area. The pressure distribution within the contact area, whether it is vertical, centripetal or unidirectional, is not normally uniform. The tire imprints that are taken by several researchers in different situations show that it is never uniform, but we normally consider only uniformly distributed vertical stress, which in turn is equal to the tire pressure. This simplification is made for most of the analysis, but for rigorous analysis, if somebody is trying to identify whether any failure of the pavement is associated with the non-uniform distribution of tire pressure on the pavement surface, then exact distribution can be obtained and that can be used in the analysis. Coming to what is the shape of the contact area, typically what you see on the left side of this slide, it would be something similar. The shape of this contact area depends on the inflation pressure, the age of the tire, the load that is carried, and also the pavement surface. In a typical tire imprint, you may see it to be in an elliptical shape, or you may see it as a rectangle in the front, in the center, and then on either end you can have semicircles, and you may not see it a fully contact surface, because tire is not going to be in full contact with the pavement surface. Many a time there are going to be gaps between the treads, as you can see here. As you can see in the diagram that is there on the left hand side, between the treads there are gaps. So, this is not a fully contracted area that we have here, there are going to be gaps, but normally we consider to be complete contact, and the general shape that we consider are circular, rectangular, rectangular with semicircular ends. If you want to have more rigorous analysis, more exact shapes can be considered. The most commonly considered shape is circular, as we are told. So, the area of this circular contact area by simple calculations will be wheel load divided by the contact pressure. The radius of contact area, if you are considering this to be circular contact area, the radius of contact area is the parameter that is going to be used in the analysis of pavements and in the design of pavements. For example, if you have a 20 kilonewton wheel load transmitted through a pressure of 0.7 MPa tire pressure, then the corresponding area of contact or the radius of contact can be obtained by equating the applied load to pi into radius of contact area square into 0.7. This will give you a radius of contact area of 95.365 millimeter. This is the parameter that we are going to use in pavement design. So, if you know the applied load, also know the pressure which we assume to be uniformly distributed and which also assume to be equal to the inflation pressure, then we can find out what is the radius of contact area, provided we are making an assumption of circular contact area. But a very popularly used shape for tire contact area is a rectangular having circular ends on both sides. This is the assumption that is made, that the radius of the, if you assume the total length of the tire imprint to be L, the radius of the end semicirculars circles will be taken as 0.3 L, and width would naturally be taken as 0.6 L. Then the width of the central rectangle will be 0.4, the dimensions of the rectangle will be 0.4 L multiplied by 0.6 L. So we can work out the area of this in terms of the L, and once we get the L, we can get what is the shape of this diagram. We can draw that. So the area will be given as, we have 0.4 L into 0.6 L for the rectangle, plus 2 into 1 by 2 pi 0.3 L square. This will be equal to 0.5227 into L square. This is in terms of L, which of course will be equal to applied load divided by the contact pressure. So L can be worked out if you know what is the load that we are referring to and what is the pressure that we assumed. L can be worked out. Once we have L, we can draw this diagram in terms of the cell. Let us take an example of whether we can draw this diagram for a given data of P20 and then tire pressure of 0.7 MPa. So for this P, the L will be calculated as square root of 20,000 divided by 0.5227 into 0.7. This gives us 233.8 millimeters. The total length of the tire imprint is 233.8, and radius of this will be 0.3 L. So that is equal to 70.14. So we can also obtain the other dimensions as 93.52 and this to be obviously 140.3 millimeters. So once we made this assumption, now we are in a position to draw the complete shape. There are analyses wherein we can use the exact shape of the diagram. So there it is necessary that we draw the shape making assumptions like this. We can also consider this to be rectangular contact area, making the same assumption of 0.6 L to be the width. We can make slight adjustment to the total length. So then if the total area, as we had seen earlier, is 0.5227 L square, the length that we consider here would be 0.8712 L. So instead of, for a particular purpose, we want to further simplify the load contact area. This can be simplified as a rectangular area given by 0.6 L as the width and then 0.8712 L as the length. Among the design considerations that we have to have for selecting design loading, we have to appreciate that traffic loads are applied over several years. These several years could be design life 10 years, 15 years that we select. and traffic volumes normally increase each year in most cases. In some cases, because of certain reasons, there is a new road that is constructed nearby, the traffic has been diverted there, it is quite possible the traffic volumes on a given road can get reduced also. But in normal situations, unless there are no such major activities that are taking place, traffic volumes gradually increase. We also need to appreciate that all these vehicles do not carry the same amount of load, each vehicle carries different load. And also the vehicles on different facilities, as we just said, carry different loads, each vehicle has got different load carrying capability. The wheel loads are applied over different portions of the pavement. All these wheels do not pass through the same point. That means a particular point on the pavement do not carry all the wheel loads of all the vehicles. They get distributed over various points on the pavement Also, the manner of transmission of load to the pavement depends on the speed of the vehicle. So, we need to consider what type of vehicles use the facility, what is the type of load that they carry, how these vehicles are distributed across the pavement width, and also what is the speed at which these vehicles are traveling. Are they slow moving vehicles, are they fast moving vehicle, are they stationary vehicles. Accordingly, we will be selecting appropriate input parameters for design. Pavement is designed to carry traffic loads over a specified period, this was mentioned earlier. Thus, it is very important to have an accurate estimate of the total number of vehicles that are expected to use the facility during the design life period. If you consider the design life period to be 15 years, how many vehicles are going to be utilizing the facility, we have to estimate. Naturally, we will not be in a position to observe these things because this is future. On the basis of the information that is available today, either on this facility or on similar facilities elsewhere, we should be able to make prediction about how many vehicles will be utilizing this facility and then how many commercial vehicles will be utilizing this facility, because as far as the pavement is concerned, we are interested in the number of commercial vehicles that are going to utilize the facility. This is what we call as traffic forecast. I am sure that you learned something about traffic forecast and traffic volumes in your previous lectures. It will also be very useful in the design if the traffic volumes can be estimated for different design periods. Rather, if the total design period is 20 years, what would be the traffic volume during the next 5 years, next 10 years, next 15 years? If we can have predictions that can be made for different periods, sub periods of the total period, that will help us in making various strategies like going for high initial cost, different types of maintenance strategies at 5 years, 10 years intervals, or other strategies which we can make based on how the traffic is going to be distributed over the entire design period. The traffic estimates can be done from the traffic volumes prevailing in a base year on the particular facility or on similar facilities elsewhere in a base year, and by selecting appropriate growth factors and appropriate projection techniques. For forecasting traffic, a typical approach followed by Indian Roads Congress given by IRC 37 code for projection of traffic over the design life period is given as, this is in terms of the cumulative traffic, total number of vehicles, commercial vehicles for the design period, given as N, that is 365 multiplied by A, and we also take into consideration a factor R, and N, small n, is the design period. Okay. We will explain what these individual parameters are, where A is the initial design traffic in the year of completion of construction in terms of number of commercial vehicles per day. At this moment, we are only talking about number of commercial vehicles per day, and we are also only trying to estimate over the design life period how many total number of cumulative commercial vehicles are going to be. In fact, the actual design parameter that we need is these number of commercial vehicles will have to be converted into equivalent number of standard loads, but we are not going to discuss that aspect in this lesson. That will be followed in the next lesson. So at this stage we are only trying to estimate what is the cumulative number of commercial vehicles that will be there during the design life period. Design life period being n number of years. We also use the term initial design traffic. When we say design, this A has been appropriately selected. This is not just the number that were counted, appropriately selected by taking into consideration how these vehicles get distributed across the width of the pavement, also taking into consideration that all the wheels are not placed along a particular line, because all those loads are placed across the pavement width. We also need to take this into consideration and select the design period, select the design traffic. So the parameter R that was used in the previous expression is the annual growth rate of commercial vehicles expressed as a fraction. The annual growth rate will be different for different states, different for different facilities. This can be estimated, or if it is very difficult to estimate, we can follow the IRC guidelines that are available. IRC suggests that we can use this, consider this to be about 7.5% in case no other data is available. Small n is the design period given in terms of years, 15 years or 20 years. The traffic in the era of completion of construction, that is A, that is what we have used in the previous expression, because we might have measured the traffic in 2005, but the construction of pavement would be complete by 2007, and the pavement is subjected to actual number of loads would have to be counted from 2007. So what would be the initial traffic in the year of 2007 has to be estimated. From that area onwards, what would be the cumulative number of commercial vehicles can be estimated from the previous expression. So the traffic in the era of completion of construction can be estimated using the following expression: A is equal to P into 1 plus R to the power X, where P is the number of commercial vehicles as per the last count. Either the traffic has been taken 2 years back, either it has been taken this year. So when was the traffic counted? With reference to that, what was the traffic volume in that year, and X is the number of years between the last count and era of completion of construction. If the traffic count was taken in 2003 and we have started the process now and the pavement is going to be constructed in 2007, X would be 4. Okay. The cumulative traffic, which is in terms of commercial vehicles for design period N, will have to be adjusted for the directional distribution of traffic. Normally the parameter A is projected as a total two-way traffic. We are not going to be making projections for each lane, for each direction. Normally what we get is the total two-way volume projected. So naturally that has to be adjusted for how much traffic is going to be going in one direction. You can assume it to be 50% in each direction, but during peak periods one of these directions may be carrying more traffic. It could be 60% this direction, 40% in the other direction. So 60% of the traffic is going to be traveling in the peak direction. It is going to be utilizing maybe 50% of the pavement area. So we need to consider that 60% to be critical. So we have to have some understanding of what is the directional distribution of traffic. We also have to have some information about how the vehicles are going to be placed across the carriageway width. That means we have to have information on lateral placement characteristics of these vehicles on the pavement. We also have to have some idea about the load spectrum. What are the loads that are carried by different types of vehicle? Some of these vehicles may be empty, some may be very heavily loaded, some may be loaded to extents that are way above the loads, legally permissible loads that we have mentioned earlier for different types of vehicles having different axles. What are the legally permissible limits would be obtained by the values given by IRC, but most of the time many of these vehicles carry more loads, overloading is always there. So we have to have an idea about the load spectrum of the loads that are carried by different vehicles. This is essential to get the design traffic which we use to design payments. Let us take an example of typical traffic forecast that we can do. For example, we are trying to estimate traffic, design traffic, where the average two-way traffic volume per day, we are referring to two-way traffic, this is a per day volume, this is a commercial traffic. On an existing two-lane highway, the traffic was counted in 2000. So, the number of commercial vehicles, total two-way number of vehicles counted in 2005 is 4000. We have assumed the annual rate of growth of commercial vehicles to be 7%, R is equal to 7%, and we are going to design the payment for 15-year design life period, and the construction of the road is expected to be completed in the year 2007. So, let us see whether we can estimate how we estimate the cumulative traffic. So, the cumulative traffic, first of all we will try to estimate what would be the traffic in the base year, or that in the year of construction of traffic, construction of the road, which is given as 1 plus r to the power x. R is the traffic that were counted in the year of count, which was in 2005. So, given as 4000 into 1 plus rate of growth expressed as fraction to the power 2. The difference between the year of construction and the year of count is 2 years. So, this will give us 4580 commercial vehicle per day CVPD, commercial vehicles per day. So, the cumulative traffic over this 15-year period will be estimated as 365 into this A 4580 into 1 plus rate of traffic growth to the power design number of years 15 minus 1 divided by rate of growth. This is equal to 42 million commercial vehicles. Of course, in this case we have not considered two important features of traffic. We have not considered what is the lateral distribution out of this 4580, how they are spread across the pavement, that we have not considered at this stage. We also not consider the load spectrum of these vehicles, that also has to be adjusted. Okay. As we said, that aspect we are not going to cover in this lesson. Okay. Coming to the lateral distribution of wheel loads, we have been talking about this, that we cannot expect that all the wheels will be traveling along the same path, they follow the same path. They are going to be distributed laterally, taking different positions on the pavement depending on the traffic volumes, depending on whether it is 1-lane road, 2-lane road, 3-lane road, multi-lane road. All the commercial vehicles do not take the same lateral position on the highway. Depending on the type of facility, whether it is 2-lane, multi-lane, the number of lanes that the facility has got, the paths that the wheels of commercial vehicles tread differ. As a result, all the wheels of all the commercial vehicles utilizing the pavement during the design period do not stress, do not load the same point on the pavement. So, a particular stretch, particular portion of the pavement carries only a certain portion of all the wheel loads. We have to identify which is the critical portion of the pavement that carries the maximum percentage of wheel loads. What is that percentage? If you know what is the total commercial vehicles, So, we have to take only certain percentage of the total commercial vehicles as the design traffic, and we also identify which portion is more critical. It is actually, we can easily identify on many highways. If you see a certain portion of the road is more damaged compared to any other portion, you can also see, if you observe that the wheel loads, most of the wheel loads would be traveling along the damaged path only, unless we have serious potholes and other things there. Normally that is the portion that gets stressed most of the time. As a result, that is the portion that gets damaged also more frequently. So, each part of the pavement gets different repetitions of loads. We have to identify what is the percentage of this repetitions out of the total, and also maybe which portion is more critical. To understand the lateral distribution of wheel loads, for example, if you take a 2-lane road, okay, and if you consider a vehicle moving in this direction, and there is another vehicle moving in the other direction, depending on the width of the carriageway, depending on the width of each lane, and also depending on the size of each vehicle, so the position of these wheel loads with reference to the other wheel will be can be assessed. So, we can see each portion of this 2-lane carriageway would be carrying number of wheel loads. At times a portion of this can be having wheel loads from both directions. So, there is going to be some overlap between the wheel loads placed for the vehicles traveling in both the directions. So, we have to identify which portion of the 2-lane road has got maximum overlap. Most of the time it is the central portion that carries wheel loads traveling in the direction and also wheel loads traveling in the direction, but we have to make some observations about how the wheel loads are placed across the carriageway and which portion carries maximum wheel loads, what percentage, that has to be identified. For example, if you have a typical multi-lane, there is a 4-lane divided carriageway. So, you can have 2 lanes, 2 vehicles traveling in this direction, simultaneously you can have 2 vehicles traveling in the direction. But if it is a separated carriageway having a median in between, so these vehicles are physically separated from the vehicles that are there on the right side. So, there can be only overlap of vehicle paths of the vehicles traveling in a particular direction. So, as you can see here, the central portion gets loaded by the left hand side and right hand side wheels of the vehicles traveling in the same direction. So, we have to identify that patch, and also maybe we have to estimate what is the percentage of vehicles having their wheels in this patch. This shows a typical distribution of wheel load placement across the carriageway width of a 2-lane road, which was about 7 meter wide, which was divided into 25 centimeter patches. As you can see that most of the wheel loads were placed at the center of the 2-lane carriageway at a distance of about 3.5 from the pavement edge. This is because wheel loads from left, wheel loads from right, they get overlapped around that portion. So, that is the portion which carries maximum wheel loads. So, we identify whether it is the central 1 meter that is important, central half a meter that is important, and what is the percentage. Considering the central 1 meter to be important, about 51% of the total traffic assumes positions within the central 1 meter of the 7 meter carriageway width. Let us see the Indian Roads Congress recommendations for the percentage of traffic that is to be considered, taking into consideration the lateral placement characteristics of different types of vehicles on different types of facilities. If you consider single lane roads, the design is based on the total number of commercial vehicles in both the directions, because single lane roads do not really have enough space for the wheels to be placed at different locations. So, we find them more or less to be channelized, they follow more or less the same path. So it is a fair assumption to make that 100% of the vehicles can be considered for design. Similarly, if you are considering 2-lane single carriageway roads, about 75% of the total two-way traffic can be considered for design purpose. For 4-lane single carriageway roads, the design has to be based on 40% of the total number of commercial vehicles in both the directions. 4-lane single carriageway road means you have 4 lanes, but these are not divided, there is no median between them. So there is a possibility of overlap of vehicles traveling in the direction. We normally assume that 2 lanes will be utilized by vehicles traveling in one direction, other 2 lanes by vehicles traveling from the other direction, but there is always a possibility of overlap of these vehicles going into the other lanes. Okay. So it is 40% of the total two-way volume, that is what we have to consider in the case of 4-lane single carriageway road. If you have dual carriage roads, the lanes that are meant for a single direction are separate, and similarly there will be separate lanes for exclusively meant for traffic coming from the other direction. There cannot be any interaction between these two traffic in these two directions. In such a case, if you are designing dual 2-lane carriageways, that means in each direction you have 2 lanes, 75% of the number of commercial vehicles in each direction has to be taken for designing that. Whereas in the earlier case it was 40% of the total two-way volume, in this case it is 75% of the traffic traveling in that direction. For dual 3-lane carriageway, in each direction you have 3 lanes separated, and dual 4-lane carriageway, the percentage that we have to take is about 60% and 40% respectively. To summarize, in this lesson we have discussed about different configurations of commercial vehicles. We have also discussed about the manner in which the load is transmitted to the pavement through a pneumatic tire. We also discussed about the need to consider the lateral placement characteristics of wheel loads of commercial vehicles, and we have also seen about the methods or approaches that can be used for estimating the design traffic. But it is true that we have not completely covered the aspect of how to exactly estimate the total design traffic, because we have not discussed the aspect of converting the given number of commercial vehicles into equivalent standard loads. This is an aspect that we are going to discuss in the next lecture. Let us take up some questions from lesson 4.2. As is customary, we will provide answers to these questions in the next lesson. The first question is, what are commercial vehicles? Why do we consider only these commercial vehicles, rather only commercial vehicles for pavement design? The second question is, what is the legally permissible gross weight for a vehicle having 2 axles? Front axle has single wheels and rear axle has dual wheel sets. So what is the total legally permissible gross weight for this vehicle having 2 axles, front axle having 2 single wheels on either end and rear axle having dual wheels on either end? Work out, the third question is, work out different typical load contact shapes that can be considered for a single wheel of 20 kN load and a tire pressure of 0.6 MPa, circular, rectangle and other shapes that we have discussed earlier. So you have to work out different shapes for a given load and given contact area. What are the different shapes that we consider and what are the dimensions? Question 4, for a 6-lane divided highway carrying a total two-way volume of 8,000 commercial vehicles per day with a 50-50 directional split, in each direction the traffic is 50%. What is the design daily traffic in terms of commercial vehicles? Now let us discuss the answers for the questions that I asked in lesson 4.1, which was on principles of pavement design. Are pavements important enough to demand the services of specialists for design? We had discussed in the last lesson, because most often payment design is neglected because the failures are not spectacular, they do not create so much of maybe nuisance or danger for immediate danger for users, but the deterioration is very slow. But it is very important considering the amount of money that is invested in constructing the payments and money that is used or spent for maintaining them in proper shape on a regular basis, that is huge amount of money, and also money that is lost because of improperly constructed roads, improperly designed roads. Lot of money is lost because of in terms of road user cost. It is very essential that the resources that are utilized in terms of the materials, what is the contribution of each layer, what happens if a thicker layer is used, what happens if better materials are used, what is the contribution. We need to understand this thoroughly. As a result, this is not a layman's job, this has to be an specialist job nowadays. How do you differentiate between flexible and rigid payments? Flexible and rigid payments are typically differentiated in terms of the load spreading capabilities. Typically, flexible payments have materials that distribute load from top layer to bottom layer, but the rigidity of each one of these layers, stiffness of each one of these layers, top one will be better more than the lower layer, but the difference will not be so significant as we compare in the case of a concrete payment or rigid payment. In the case of rigid payment, the concrete payment is going to be much stiffer than the foundation, and as a result the contribution of rigid payment foundation in rigid payment is not going to be very significant. How do you distinguish between functional and structural failures of payment? Functional failure or functional performance is from the point of view of the road user. Road user wants comfortable, safe riding surface. So this is directly correlated to the surface characteristics of the road, whereas structural failure is caused by the loads, which would be in terms of fatigue cracking, which would be in terms of permanent deformation, rutting. So this is how these two performance criteria or failures are different. What are the main external parameters influencing payment design? This were discussed in the lesson also. The main external parameters are subgrade, traffic loads and climatic factors. What is the difference between empirical and mechanistic approaches of payment design? Empirical is the design that is developed or criteria that is developed based on experience and some simple parameters, whereas in mechanistic approach the experience is correlated to some mechanistic parameters like stress, strain and other critical parameters. What are the main disadvantages of designing payments following empirical criteria? Because this is based on past experience, based on some statistical correlation, this cannot be extrapolated to new conditions, new materials, new traffic conditions. Can be done, but not with a great deal of confidence. So with this we conclude lesson 4.2. Thank you.